All right, this week we're going to kind of continue with light frame construction. We're going to talk about exterior finishes for wood light frame construction. And even though it says wood light construction, I think we can all agree that the exterior finishes would cover any type of construction. The major theme that we're looking at this week is keeping moisture and water out of a building, and how we do that through sidings and roofing protection, and how everything kind of fits together to dissipate and move water away from the building. I think aside from fire, probably moisture is one of the biggest destroyers of buildings when we start talking about mold and rot and termites. Termites love good moist wood. Carpenter ants, of course, are a big issue up in this area now that things have kind of warmed up a little bit. We're finding that migration becoming further and further north. So we're going to take a look at this chapter. I've actually taken the entire chapter and made a PDF, so that will be uploaded onto Blackboard. We'll take a look and get through this thing. There we go. We're going to first start with roofing and looking at underlayments. So some of this is probably hard to read, so I'm going to zoom in on some of this information and talk about, first of all, roofing underlayments. Whenever we shingle or put a roof down, we normally would put an underlayment down. Some of the sheathing manufacturers claim you don't need this, but most people will put at least some roofing underlayment on top of the substrate that is your roof sheathing. And that can be in the form of, it's rain and ice shield, which is a rubberized material that self-adheres to the roof membrane. And, oops, a little off here. Let me push this over. I guess it's not gonna. Maybe I can move my box. There we go. And so the roofing underlayment is installed soon after the roof frame is complete and sheathed. That's with plywood. Most common is building felt. Normally it's matted cellulose fiber saturated with asphalt, and we refer to it as tar paper or asphalt paper. And that comes in different weights. It's rolled out, stapled onto the roof, and it gives that extra layer of protection on the roof itself. Other types of interior weatherproofing would include, let me see if I can pull up here a little bit. Not that far, sorry. Probably easier just to sink through this way. There we go. They have synthetic roofing underlayments, which is what I talked. It's a polyethylene fabric. Now, most of this stuff isn't totally waterproof. It is breathable. We want to be able to allow the building to breathe somewhat. Wall moisture barriers, we have material like house wrap. Normally we refer to it as Tyvek, which is the brand name. But the house wrap is a synthetic fiber manufactured in sheets as wide as 10 feet. And we see this stuff a lot of times. The building manufacturers will put advertising on it, like Hammond lumber, but it's basically just a synthetic material that allows the building to breathe, but still keeps the moisture, for the most part, out of the building. Gives us not necessarily for totally airtight. They refer to it as more airtight, but we want to be able to sheathe and really get that water out of the building. See if we can get to the next page here. There we go. So here we see the Tyvek material. That's a brand name. It's not actually a material. So you might see Hammond lumber, but they'll cover the entire building with this type of material to give it some additional weatherproofing. The other thing, while we've got this photograph on the screen, is I want to mention that the edges of the roof. This edge, the horizontal edge of the roof, is referred to as the eave. The sloped edge of the roof is referred to as the rake, R-A-K-E and E-A-V-E. You probably will see that somewhere in this chapter. So when we look at details, it'll either be the rake end or the eave detail to get you kind of oriented. See if there's anything down below here. There's some details. The edge of the roof, this would be looking at the sloped edge of the roof. You can see there's a rake board. We have a little spacer strip because we need to space out our siding. If we didn't have this, this raker board would actually be leaned in. We have some material made out of normally metal called a drip edge, which is just a formed continuous strip of metal that allows the water to drip away from the building. As it falls off the roof or gets blown off the roof, the water will drip and come out off this edge. Otherwise, we would have something that would allow the water to just follow its path even horizontally. It has that ability to kind of stick to things and then drip down and get into the wood. So this drip edge keeps the water from kind of following its path with its ability to kind of stick to things. So we have a couple different details. There's our siding, a spacer strip, and our roofing. There's our sheathing, and there's our roof rafters. Another detail, these are just two typical details. This one being if it's right to the edge of the siding. It's always nice to have an overhang on your roof in light frame construction. Here's that description of eaves and rakes. Eaves being the horizontal roof edge, rakes being the sloping roof edges. We have our roof rafters. This is our fly rafter here. Our regular roof rafters over here. Our rake boards and roof sheathing, asphalt. Again, the drip edge is on the side, and then another spacer and some siding. There's our exterior wood studding and our sheathing. A typical detail for a eave edge, we have our gutters. This is wood. We don't see wood gutters too much anymore unless you're doing a historical building. But it's important to note that we have something called a vent spacer here. We'll look at that a little bit later on. This symbol indicates insulation in the attic space or the ceiling area. Insulation in the walls, double top plate, sheathing, siding, wood trim, our lookout boards here. We also have a ventilated screen that allows air to get up inside the rafter area and flow into the attic space. We want to be able to get air into the building for a couple reasons. One is health of the occupants and the building itself, and the other is for prevention of heat buildup or moisture buildup in the attic space, causing the roof to sag or become a mold area. This is our fascia, which is the piece across the front edge. This is a soffit, is the horizontal piece that closes in that overhang. In this case, it's plywood. If you have vinyl siding, sometimes this is plastic, a ventilated plastic material that allows air to get in. But it's horizontal, so it keeps the water out, but allows air to flow up inside the building. Another detail here, less common, we have no fascia, we just have a soffit where this stuff is brought right down onto it. So it's similar, we still have the vent spacer, we still have the airflow coming in. And a little more common where we have aluminum or vinyl gutters, drip edge, roofing, aluminum or vinyl siding, aluminum or vinyl soffit, insulation in the ceiling. So everything is about good insulation and good water removal from the building. Hopefully you're getting all that stuff. I keep forgetting to move this screen around so you can see, so I apologize for that. But again, this is all in the handout that you'll be downloading from the Blackboard site. Just an illustration of some gutter material in the building. This is aluminum. Again, we don't see that too much. There's our soffit, our fascia board. This end cap just kind of closes off the end of the building, and then we've got, looks like aluminum siding into the bottom. And for years we had aluminum gutters all over, and that aluminum gutter gets the water away from the building. We don't see internal or sealed gutters or concealed gutters anymore to speak of, except in low sloped roofs or flat roofs. We have internal gutters that actually drain the water to the center of the building and then drop it down inside the building itself. And we're finding some aspects now where that water is able to be recycled and used for gray water applications, such as flushing toilets, for instance, and that type of thing. We want to get the water, once it comes down the gutter, away from the building. We use things like splash blocks, and anything that will get the water away from the foundation is important. Now here's we talk about insulated roofs. Especially in this country, we have problems with ice dams. We can see the word here, ice dam, and that is this item right here. Now, you just have to kind of think through this all the way through. If we have a poorly insulated attic and we have heat in the building, that heat's going to get up into this attic space. And when it does, what happens is it's going to start melting this snow load on the top. As that melts, it's going to melt from the bottom, and water is going to run down the roof, and suddenly it's going to hit this cold edge. Because this portion of the roof doesn't have heat coming up through, and obviously heat rises, this stays very cold, this portion of the roof. So it will start to refreeze, this water melting down, and we end up with this buildup of ice on the edge of the roof. So pull this over so you can see it better, sorry. So here is the the heat again, the ice melting, causing this ice dam. So to prevent this, it's important to keep our attic space, or the space above our insulated portion in the roof, cold, so that the snow melts uniformly all the way down. If we can keep this temperature the same as this temperature, then at least any melting will happen uniformly. If you have an ice dam like this, it's possible for moisture to work its way back up underneath asphalt shingles or roofing and then leak into the building. So the older the roof is, the more brittle the shingles are. They may be broken, or a couple have blown off with the wind. We need to be careful of that. If we look down here, we can see a well insulated roof where the heat is kept inside. The insulation is enough to keep the heat from getting into the attic space, and through this soffit vent and this vent spacer, we're able to allow cold air to get inside the attic space and keep this roof snow from melting. That's a very important part of building, especially in the Northeast or any cold climate where we get a lot of snow, and if we have poorly insulated homes. If we have a cathedral ceiling, we can still apply the same logic. If we have insulation and we have a spacer between that allows air, cold air, to flow between the spacer and the underlayment, it's still going to keep that roof cool. Now we do have unventilated. Now this is this is that vent spacer that we just saw on Eve that allows air to flow up above the insulation into the roof area. It's only about 2 feet long. It just needs to be up above the insulation so air will flow out here and keep the attic cool. These are very inexpensive. They're like styrofoam egg crate type material, so they're very delicate too. They don't hold up very well, but they're only there for moving air, so it really doesn't have to be anything very spectacular or heavy duty. Soffit vents, again, it just describes what those can be. And we also have ridge vents, somewhere that cold air's got to get out. So we have a vent in the ridge or in the gable ends of the roof up in the peak, or it could just be a metal ventilator that allows the air to escape out through the top of the roof. So we try to look at making that work. Here's an unventilated roof, and we're going to look at some details of that here in a second. There's our soffit vent. It's perforated aluminum inside this plywood material. Again, sorry to move you around. There we go. And there's a ridge vent. This is generally just an asphalt cap or a plastic cap that sits on the top. It has almost like a plastic expanded steel wool looking material that prevents leaves and other materials from blowing inside and clogging it up. It also keeps rodents from getting into the building. So that also has to be an aspect, that any ventilation that you put into the attic space should be screened so that small varmints can't get inside there. We do have details where if the insulation is right up tight to the roof and we use the proper ice barriers, we don't need that. So this would be, say, a timber framed home where we have tongue and groove wood ceiling areas, exposed beams, insulated walls. This may be a SIPS panel, a structural insulated panel that sits on top and provides continuous insulation all the way through. So again, we're going to get that same uniform heat distribution. So it is possible to use non-ventilated areas in places where there are no air spaces for the moisture or the water to travel. If you get heated moisture in this area, it's going to weaken the wood structure and cause possibly the ceiling to start, or the roofs to start to sag, and that's something you don't want. You can also use spray foam insulation. You can see here where the spray foam is actually put right through to the underside. Again, it's uniform. The heat would not get through to the roof side, so if it's well insulated enough, the ventilation becomes less of a important factor. But anytime you've got a horizontal roof, you're eventually going to, this area could end up being warmer than this area. You could end up with ice dams, which is, of course, a problem. Let's take a look at roof shingling, and of course the most common being asphalt shingles. And we're also going to look at flashing for windows and doors. Here we have a person applying roof shingles. Asphalt shingles over roofing felt. There's your tar paper. We have these little asphalt daubs on the shingles, so as each layer is put on and nailed down with the natural use of the sun heating up the roof surface, these little daubs of asphalt will melt and tack down that shingle. So when you have to go up a while later, say a year or so, you have to kind of pry those shingles up. Hopefully, if they don't stick, then we've got an issue. But most times they'll stick down to the point where wind won't lift them up. The lower the pitch roof, 312, 412, 512, you've got more horizontal edge exposed to the wind, so more chance of those shingles lifting up and getting blown off in a windstorm. The steeper the roof, the less chance you have of having those asphalt shingles blow away. But it is a good, common, fast way to put a roof down, especially if you don't have to use a hammer. If you have a pneumatic or air gun, you can lay these down pretty quickly. They are overlapping. You can see that we do a brick pattern so that the seams don't line up. Any water getting down in here will not pass back up through. They do have jet asphalt shingles that have no tabs on them, which is fine. Some people like that look. And we have the architectural shingles that actually kind of mix up the pattern so it looks a little bit more like a cedar shingle type pattern with different size tabs. Here we have a window, a window opening. And I think this is kind of important because it shows how we layer things on. In this case, we've got a rough opening for a window. This is just plywood sheathing or another layer of Tyvek house wrap. We're going to first start by putting the sill wrap around the window area on the bottom. Then we'll actually put the window in place. This stuff is all taped on. Once the window's in place, and leveled up and plumbed and shimmed, we're going to put 2 layers of Tyvek material on each side of the window, again lapping down over the sill area so water will move down. And then finally we're going to put a strip across the top that kind of covers up all of these nail fins, these edges, and allow any water coming down would sheet off the outside. Nothing is allowed to get inside any exposed seam. This would go up far enough and be sealed down so that nothing would penetrate into that window opening. So it's important that we get that that overlapping into the window flashing. Again, we can see it here. This is some ice and water shield they're using to give it a little bit extra material. Up here on this round window, again, we're putting the Tyvek in there and lapping it to make sure that everything is in place and watertight. We'll talk a little bit more about installing windows and doors. There is a nail fin or flanged window and a flangeless window. A lot of times this has to do with whether you're putting the window in as a replacement or whether it's new construction and just how it goes into the openings. 6-panel wood door. It's we look at this closely and base it on this door here. We have, I'm going to move this over so you can see it, a head, whoops, there we go, a jamb, and a sill. The head is looking, we take a cross section, we're going to look right through this area of the door in this direction. So we're going to see the outside casing, the inside casing, this should look familiar, the door header or the top stop for the door frame, weather stripping, the actual door panel itself, so this door is going to swing in, it goes right up against this stop, and we have our header construction, our outside siding, and flashing that keeps water from getting in behind this area and causing it to come down into the door frame. If we're able to look through the side of the jamb without these windows, it would be more over in this area looking straight down. We're going to see, of course, there's your wall studding, insulation, outside sheathing, outside siding material, door casing, door frame, door panel. Again, we've got some weather stripping and we've got this interior jamb material. So we're looking straight down in a plan view at how that door would be. Again, it matches this trim up here, but it's looking down at it, so everything is continuous all the way around. You can see these wood shingles they use as wedges to kind of square up the door inside the frame. The rough opening, generally speaking, on a door, in other words, just a studded excuse me, opening, is probably 1/4 to 3/8 of an inch larger than the actual size of the door frame itself. So it allows you the ability to square that door up, make sure everything is true and plumb so that the door will open and close properly, it doesn't get stuck. And so using these shingles allows us to kind of square up particular areas. Down on the bottom we have a sill. The sill is the door stoop, or this portion right here, that again allows water to slope away. There's your finished floor, your subfloor, your roof joists, or your floor joists, your header or banding around the outside of the floor joist, your outside siding, and your there could be some clapboards or some type of material on the underside, and then flashing. We got a rain drip here on the edge of the door that keeps water again from getting, if you got a rainy day and the wind is blowing from this direction, you could end up having water blow underneath the door sill and into the home. I've actually seen that happen in my own place. So having a rain drip and some weather stripping keeps that from happening. It takes this particular wind direction to make that happen, but it does happen occasionally. There's our door panel, our sill, and our backside of our casing is right here. So when you're looking at drawings of doors and windows, you're going to see details for head, jamb, and sill for particular types of doors within the building drawing package. So You may see several of these in a building for different types of wall conditions, exterior, interior, different types of doors. Anything could cause a different, but if they're typical, they'll show one detail to cover a specific type of door within the door schedule. Let's move down. Paints and coatings, exterior. Important to note that most architectural coatings, whoops, let me get this over so you can see it, sorry, are formulated with 4 types of ingredients: vehicles, solvents, pigments, and additives. A vehicle or binder provides adhesion to a substrate and forms a film over it. This is also referred to as the film former. Okay, there's something in that paint material that allows it to stick to particular types of materials, and that's why on the paint can itself it will tell you this is designed for wood, plastic, metal, masonry. Those things are what that binder or vehicle is formulated to stick to. So if you use it on something else, there's a chance it could roll off. Solvents, the volatile liquids used to improve the working properties of the paint or coating. The most common solvent used in coating materials is water. But we also have, that would be your latex or water-based paint. You also have turpentine, alcohols, ketones, esters are also used. Any type of oil-based paint would have that type of thing, where in order to clean it, you need to use additional solvent materials. Pigments, finely divided solids that add color, opacity, and gloss control to the coating systems. They also impart hardness, abrasion, resistance, and weatherability. And then we have some other additives, some that allow it to dry quicker. Others may relate to ease of application, resistance and fading, UV ratings, and that type of thing. So vehicles, solvents, and pigments. If we look down here, here's our 2 types. We have solvent-based or oil paints and water-based or latex. Oil paints are also known as alkyd paints, A-L-K-Y-D, and water-based paints, of course, are known as latex, so you can clean them with water. That is the solvent that keeps it viable. A lot of times your solvents, if it's a water-based paint, will have an acrylic in it, so that when it does cure, it becomes kind of plastic, so it's no longer dissolvable by water. You can't put water and reactivate it. So that's why we can still use most latex design paints outside, because once they set up, they are not affected by water. Move this over a little bit. Many solvent-based coatings also emit, this is oil-based or water-based, but mostly oil-based, a significant VOC, volatile organic compounds. When doing work on a building, especially this is more important when you're inside a building, but these compounds can make some people ill. They just give off an odor. They're kind of nasty, so a lot of requirements and specifications need a specific low VOC. And if you're getting LEED certification, that's certainly another aspect of it that needs to be included in the process, that you make sure that the manufacturer is providing you with a low VOC, if it's required, material to prevent any type of off-gassing, for instance, or any kind of nasty stuff that might happen. Interior is, of course, much more important, because you may have people working in there that could get sick from some type of VOC. And it's not to say the VOCs are just when the paint is applied. Some particular coatings could give off VOCs for a long period of time after they're placed in service. So that's important to keep in mind. Paints contain relatively high amounts of pigment. The highest pigment content is in flat paints, those that dry completely to a matte surface. Paints that produce glossier surface are referred to as enamels. A high gloss enamel contains a high proportion of vehicle and a relatively low proportion of pigment. The vehicle cures to form a hard, shiny film in which the pigment is fully submerged. Semi-gloss enamel has a somewhat lower proportion of vehicle, though still more than flat paint. So we have flats, we have matte finish or semi-gloss. Eggshell is one interpretation of that I'm more familiar with. We use a lot of eggshell on walls, for instance. So it's washable, doesn't peel off like flat paint would, but it still doesn't shine. One of the things that is important to recognize with paints on the outside is the higher the gloss, the more it's going to show the defects. You'd be able to see, if you put a high gloss finish on a wall and there's any kind of nail indentations or stud locations or any kind of defects in the wall, you're going to see it, especially when the lights are on just the right way. Whereas flat paint will hide a lot of your mistakes, so I use a lot of flat paint. Stains are transparent or semi-transparent. We'd use this on a lot of wood surfaces. You might use it on exterior siding for cedar shingles, that type of thing. Clear coatings, high in vehicle and solvent and contain little or no pigment. This would be your polyurethanes, varnishes, lacquers. Furniture uses a lot of shellac type materials, especially historical. It's a clear coating for interior use that is made from secretions from the lac insect, which is an Asian insect. They squeeze the little bellies on those things, and the sticky material that comes out is actually a shellac material. Dries rapidly, gives a very fine finish, highly susceptible to water by damage. So this is why Grandma always wants you to put the coaster down, because a lot of her old furniture is shellac and it will show the rings from wet cups and things. So it's a nice finish, but and I think they've probably gotten away from milking insects, but and probably have a chemically created shellac. But the real shellac, you can actually buy it in powdered cans, mix it with alcohol, and make your own. So they're more used in the furniture than anything else, but your clear coatings and your stains are still used a lot in exterior wood finishes. A lot of times we'll use a sealer on wood, unpigmented liquid that can be thought as a primer for clear coating. So sometimes you will put a sealer on the material. I'm going to scoot through this stuff. They just talk about sustainability and Green Seal. They've of course got another standard now for LEED certification that requires Green Seal 11 standards for paints and coatings. I don't need to get into that too much. Surface preparation. You can read this yourself, but just tells what type of surface preparation is required for different types of material. We'll just look at concrete walls. Must be clean and dry, at least 30 days old. You don't want to put paint on a fresh concrete because it will still be moving and drying and still has some moisture on the inside. You want to use a masonry primer where required and 2 coats of latex paint. And so you can get down through that material. Gypsum board, wood windows, concrete hardwood floors. Siding. Different types of exterior, and this is wood siding. We have our standard clapboards. We have, make sure I get this over so you can read it. There we go. Plain bevel siding, rabbited. So you can see this rabbet is just this little indent in the bottom of the siding. We have V shiplap, which is again just a beveled siding so that it's more flat, less tapered on the edges. Oops. We have a cove shiplap, so this is all wood siding on the outside. A V-groove, tongue and groove material where we have a tongue and a groove that this stuff just slots into. We'd see this on like pine You see this more like on interior finishes as opposed to exterior. And then this is board and batten, and the difference here is you're looking down at it from the top. So it has boards, say 12-inch boards, 3/4 of an inch, and then at the seams it has a strip of wood that gets nailed through it to hide the seam, give it a little bit of trim, more of a camp type feel and something you might see on a residential home or a building. This is something called rain screen, where we put furring strips. There's your outside sheathing, your air and moisture barrier, Tyvek, and we put a 1x3 vertical spacing wood strip on the studs. We put our siding nailed to those strips, and what this does is it allows the rain that gets in behind here, any moisture that gets into the wall, to run down the outside of the wall and escape through the bottom rather than setting there and weeping into the building. We also put a folded strip of insect screening on the bottom to prevent any type of insects from getting up inside this cavity and making themselves a nice home. This would be hornets, bees, that type of thing, or carpenter ants if they want to get a little easier way to get into the building. So that's a rain screen. Here we have some exterior, it's like redwood or cedar vertical siding. Down the bottom, find out exactly what it is. Completing a tongue and groove siding on the outside of a building. We don't see that too much up here. It's expensive. It might be more prevalent on the West Coast or having lots of money, but it does look nice. Plywood siding. Plywood siding is nothing more than 4x8 sheets of paneling. Believe it or not, this plywood siding was started by Sears and Roebuck. Used to sell prefabricated home material, more of a hardware supplier. It's 4x8 sheets. You can see that this is the 8-foot length, or excuse me, this is the 8-foot length. They use a Z-strip of aluminum in between each sheet to keep the water from getting inside. These are just stained. It's basically the ability to create a sheathing and siding combination all together. So we can see here we have the exterior panelized sheathing. It's also the T111, so it has a stainable exterior finish that can be painted. They use an aluminum material as a spacer in between. And then the plywood becomes the siding and the finish, so it's a little more economical to put on. It does look nice on a home if it's done right. My brother lives in a neighborhood in Kansas that every home has this on the outside, and it's in that particular area all the homes are the same, so it looks nice, but it is sometimes referred to as a little less expensive because it is less labor intensive to put it in. It can be made nice. Here are cedar shingles. If you have the time and the energy and the money, you can put on cedar shingles. And these are just lapped on like roof shingles. They're nailed, overlapped, whatever exposure you want, and staggered. So there are a couple different ways to put these on when you hit corners. You can see this one is kind of an interlaced corner. He's just going around. I believe there's a picture here in the next section that shows this is what we just looked at. Some people don't want to mess with trying to weave these things in together. They'll just put corner boards on, and on an interior corner just put a blocking in there so they can just butt up to the edge of this material. Again, you can see the asphalt impregnated paper in the back, the tar paper over the sheathing, and then this cedar material is just on the top. So that's a couple different ways to, whoops, I guess you didn't see that one. Come on. Well, there we go. So there's that weaved area and the corner area. I'm trying to zoom in on this so you can see it better, but unfortunately I'm forgetting. I get to talking and I forget to move it forward. My favorite, metal and plastic siding, vinyl siding. has come a long way. There were a number of years where vinyl siding would chalk, wasn't really good against UV, was very brittle once it got exposed to the sun for any length of time. But they've improved it now, stays more flexible over a great number of years, and aluminum has kind of become too expensive to work with, but still it's something that looks good. There are some, that's wood shingles, but here's some that's fancy cut. I think they have some more, just some images of different types of exterior siding and sheathing. We're going to talk next week about interior sheathing, or excuse me, interior finishes. Got anything else? There's some vinyl siding. So you can see this stuff is just nailed at the top. It is nailed loose. This stuff will expand and contract. So if you nail it on too tight, if these roofing shingle nails get on too tight, it will buckle and not look right. So you have to keep it loose so they'll kind of move. You can kind of pick, if you grab an outside vinyl, you can kind of wiggle it. It'll stay loose on the siding. They both have this clip system, so the bottom layer slides in and locks to the bottom, and they just get nailed on the top. So you have to start from the bottom, work your way up. Most of you have probably done some vinyl siding. You can cut it with a pair of heavy scissors or tin snips. It's very easy to work with, very easy to install. It's durable, and when you're done and you have a finished product that you don't need to paint, my favorite part, and it looks good. Stucco is another option. We don't see it too much up here because of our cold weather and its inability to stand up, but out west in drier areas we see a lot of stucco being applied to buildings. It's generally sprayed on to a wire mesh type material. We have masonry veneer, bricks on the outside. Just a little note on this little detail on the side, if I can get it over there. There you go. A single layer of brick is referred to as a width of brick. We have, in this case, we have corrugated metal ties nailed to a frame. So this is a corrugated strip of metal that gets embedded into the mortar joint, the bed joint of the mortar, nailed into the siding, and that's what holds it in place. We maintain this airspace between the exterior sheathing and the brick to allow moisture to come down. And in the bottom, if you take a walk around campus, any of our brick buildings that are fairly new, if you look at the bottom, you'll notice every so many bricks, maybe 10 or 12 bricks, you'll see this little hole in the bottom. Sometimes it's got a wick of plastic sticking out of it. It is there to allow water to drain out of the building, generally right down near the foundation, and they're referred to as weep holes. So just if you happen to be walking around, just take a look and see if you can notice those things on campus. Some funky siding. We have things like manufactured stone or artificial stones, which are becoming more prevalent now. Come in panels. You can just adhere them right to the walls with cement. Fiber cement paneling siding. We don't see that too much. Here's a wood framed house with a four-sided chimney. It's got clad in stucco. Second story is clad in asphalt shingles. The panel around the entryway is a fiber cement panel, which is this material right here. Again, not something we see too much up in this area. Here's a picture of some gentlemen painting the exterior of a house. The author notes that this person here would probably not pass the OSHA test standing on the top of this little step ladder, but he's working away. Again, some of this stuff is probably a little older. This is a new textbook, but they like to keep these pictures in here, especially this one with this guy standing on the step ladder. If you hate painting, you would stay away from any type of siding that requires painting every so many years. Of course, they talk about sealant, joint sealants, and caulking. Anytime you get cracks in the siding or you want to seal something up in an area that may get some moisture, you want to use some type of caulking and sealant that is designed for that particular application. Interior caulking will break down in water, so you don't want to use it outside. It wants to be something that is weather resistant, And if it needs to be painted, some caulking cannot be painted by the same material that you might be putting on your home. So you want to make sure it is a paintable sealant if you need to use it for that particular instance. Just some more photos of exterior siding, details, some cedar shingles looks like. Got some cement board around the foundation. Exterior painting, finish grading, and landscaping. I think that the key with landscaping, if you have a home, soils tend to settle around a foundation over time, and you need to keep the soils built up. If you need to add more material, especially if you don't have gutters on your home, that water coming off the roof will eventually pack that soil down. You want to keep the soils built up so water drains away from your building as much as possible. Any water that sets in there is eventually going to find its path of least resistance and get into your home. So we with basements, in a week or so we're going to be talking about CSI, and which is Construction Specification Institute. We'll be looking at some of the specs that you have in your drawing folder material. Anything to do with exterior enclosures would fall under this CSI master format specifications. Unit masonry, manufactured stone, finished carpentry, plastic decking, plastic simulated wood trim, shingles and shake are section 073100. As you go through the process of becoming proficient with this material, it's important to recognize that each particular item in a building project has its own specific construction specification number. And that's important not so much from writing the specs, but from being able to read and look up. If you're looking for something that has to do with shingles and shakes, all of this stuff is numerically in the spec book, so you can just quickly get to 07 and then find shingles and shakes within that section. Down here at the bottom, you'll notice that windows and doors are all in Division 8, but they all have subsections for windows and a subsection for doors, and these are even divided even further. That's why there are more sets. These double zeros don't always get used, but for instance on flexible flashing it's section 076500. But if you want self-adhering sheet flashing, you have to look at 076526. Depending on the architect or the engineer determines how far down this breakdown. They may put everything under 076500 and just leave it at that, depending on the complexity of the building. But for the most part, they're breaking this down so any contractor, any builder, any owner can quickly find the specific item that they have a question on and get information on it. The last of this section has some key terms and definitions or things from this chapter. I think they're important to be able to define these. You may see some of this in your little quiz that we have next week, or the week after, I guess. So keep that in mind. There's some review questions at the end that are all part of that PDF. But that should cover us for exterior finishes in light frame construction, or basically any type of construction. We actually talked about timber framing and also some brickwork in there. But good stuff to know. And next week again we'll talk about interior finishes, including our rough in and that type of thing. So that should cover us for this week.